Students, today we are going to discuss some numerical problems related to linear motion in one dimension, right? The problem is written on this whiteboard. A car is moving along a straight highway with a speed of 126 km per hour. Is brought to stop in a distance of 200 meters. You can see this. What is the retardation of the car? How long does it take for the car to stop? The car is moving in a straight highway. What is the speed of that? Speed is 126 km per hour. First of all, what are the things given in the question is written like this. Given u is equal to 126 km per hour. 126 km per hour is equal to 126 into 5 by 18. 5 by 18 meter per second. That's equal to 35 meter per second. Right? As the car is brought to rest, its final velocity must be equal to 0. So this is the condition in linear motion. When we say that if anything is brought to rest, then the final velocity must be taken as 0. And also it is given s is equal to 200 meter. That means the body or the car is stopped. After applying brakes, the car stops in 200 meters. What is the retardation? Retardation is negative acceleration we had to calculate. That is the question about. Right? So from the given information, we can put this relation v, so u is known to us, and v is equal to 0. S is also there. A we had to calculate. So the suitable equation, what we have is equation of linear motion. Third equation of linear motion, that is v square is equal to u square plus 2as. V means final velocity, as the body is brought to rest, final velocity becomes equal to 0. That is equal to u, the value of u is 35 meter per second square. 35 meter per second. That means u square means 35 square plus 2 into a, that we don't know, into s. S is equal to 200 meters. So now a is found to be equal to minus 35 square divided by minus of 35 square. Minus of 35 square divided by 2 into 200 is equal to minus 49 by 16. Minus sign why it is? Because the bodies, when the body is brought to rest, it retards, uniform retardation, and finally it stops. Right? It is retarding, that's why. Now time you have to find out in what time it will stop after traveling a distance of 200 meters. How much time it will take after putting the brakes, after putting the brake and stopping of the body, what's the time duration? That is what we have to calculate now. For that time relation we will take v is equal to u plus 80. V means final velocity, that is equal to 0. Initial velocity is found as equal to 35, right? And acceleration of the body, you know that is minus 49 by 16 into t. So t can be calculated. T is found as equal to minus 35 to 16 divided by minus 49. That's equal 11.43 seconds we are getting, right? So this is a very simple question because we have to start with simple question only. Learners in physics must always prefer simple questions. But a lot of questions we have to do. So for a teacher in this kind of virtual class activities, teacher is not able to do many questions because writing the question itself will take a long time and explain it. And also space is this much only. So this difficulty is always there with the teacher. So your work is the complement of my work. That means when the theory and the formulae or the equations are given to you, then you have to use the equations every day. Every day. So I find the viewers are very less. This is not a good sign. You have to be interested in doing the work. Every day you have to watch the videos and see any new formula we got. How can we use the new formula? You must have a textbook also with you. So in the textbook, many problems like this are described. First of all, you do only the simple and example problems given in the textbook. So that way you will practice it. then go for higher order questions. So this is the method of learning physics. Another question described here is a ball is thrown vertically upwards with a velocity of 19.6 meter per second from the top of a tower, returns to the earth in 6 seconds. Find the height of the tower. That's the question. So in this case, somebody is standing on the top of a tower and a ball is thrown vertically upwards. Right? So this is a motion under gravity. When a body is thrown from the top of a tower, this when it leaves from your hand, the motion of the ball is a motion under gravity. It's the best example of motion under gravity. In motion under gravity, the acceleration due to gravity is taken downward, that is positive. With respect to the acceleration, the velocity must be taken as negative. That is the problem, right? So that is why u is equal to minus 19.6 meter per second written here. A is taken as positive, right? If you take a u as positive, then A must be taken as negative. So, but the thing is that always acceleration gravity is acting downwards. That is always a positive quantity. So better you don't put the acceleration negative, but you take negative because acceleration is always acting in the downward direction, that is taken as positive as the preceding. Then after 6 seconds, the body reaches to the surface of the earth. What is the surface? That means on the ground. And what is the height? So height means only one formula we have, S is equal to ut plus half at square. In this case, S means height h. That is equal to ut plus half at square. In place of A, we have G here, at square, right? That is U is minus 19.6 into 6 plus half into 9.8 into 6 square. That we are getting as equal to 58.8 meter. So I explained this question because this negative sign applied with the initial velocity, you may find some difficulty. So this is vector application. If one body u is taken as in the upper direction is taken as negative, the other must be taken as positive. So why u is taken as negative? Because acceleration due to gravity is always acting in the downward direction. That is taken as positive. Hence, with respect to acceleration gravity, the u must be taken as negative. So that is the importance of this question. Next, I am going to write another question on the board. So that is why the difficulty is that we have to write the question. Otherwise, I have to write the notes and send you. That is of no meaning. Many people are not viewing the videos. So that is a wrong trend. Very, very wrong trend. So I tell you that watch the videos every day and do some questions every day related to those things taught in the class, right? In the lecture, right? Next question I am writing is a body travels a distance. Question 3. Question 3. A body travels a distance 2 meter in 2 seconds. 2 meter in 2 seconds. And 2.2 meter. And 2.2 meter in the next 4 seconds. In the next 4 seconds. What will the velocity of the body? What will be the velocity of the body? Velocity of the body at the end of 7th second. At the end of 7th second. 7th second. From start. From start. This is the question. Right? There are two cases in this question. First case is that the first 2 seconds the body travels 2 meters. So this is case number 1 we can write. Case 1. Case 1, right? Okay. S is equal to 2 meter. And T is equal to 2 seconds. That means in the first 2 seconds the body travels 2 meters. Right? So apply the relation for displacement and the time, that is S is equal to ut plus half at square. Now S is equal to ut plus half at square. That is, this is equal to u into 2. U into 2 means 2u plus half into a into 2 square. 2 square. So you are getting an expression applying this one. You will get a relation, a relation. You will get. That means the relation for relation between u and a, we can get it. That means this is equal to 2u plus half into 4a. This 2 and 2 cancelled. So that we are getting as equal to what? That is 2 is equal to 2u plus 2a. Or u plus 2 cancelled. Or what? U plus a is equal to 1, we can write. This is equation number 1. Equation number 1, you got u plus a is equal to 1. What all things done? You have seen that, right? Case number 1, the body travels 2 meters in first 2 seconds. According to that condition, we have derived an expression and we got a condition u plus a is equal to 1. Second condition, that is very special. In the first 2 seconds, the body travels 2 meters. In the next 2 seconds, it travels 2.2 meters. Okay. So the total time in this case is for next 4 seconds. Total time from the start. Case 2, I will write. Case 2. Case 2 means both the times when added together. 2 plus 4 is equal to 6 seconds. From the start to total time is equal to 2 plus 4 is equal to 6 seconds. In 6 seconds, how much the body will be traveling? Total distance. Total distance is equal to first 2 seconds, it travels 2 meters. Next 4 seconds, it travels 2.2 meters. Therefore, total is equal to what? 4.2. 4.2 meters. The body travels in 6 seconds. Now we will take total time and total distance from the start and from another equation. That is this. That is equation is very simple to calculate. Another expression we are getting. That is 4.2 total distance traveled in 6 seconds. That is equal to ut plus half at square. U we don't know. Into t means 6 seconds. Total 6 seconds from the start. Plus half into a also we don't know. A into half a into t square. T square means 36. Why 36? 6 square. This and this cancel is equal to 18. You are getting this as equal to 6u plus 18a you are getting, right? Dividing throughout by 6, you will get. Dividing throughout by 6, dividing. Now, dividing throughout by 6, you will get 4.2 divided by 6 is equal to 0.7. That is equal to u plus a. That is equal to u plus 3a, sorry. U plus 3. This is equation number 2. Right? Now we have equation number 1 and also equation number 2. I am writing these 2 equations once again. That is like this. That is first equation I am writing here. That is u plus a is equal to 1. The other one is u plus 3a is equal to 0.7. Then subtracting one from the other, what we are getting is